It begins without a sound. One moment, the world hums with the familiar chorus of digital existence. The next, an absolute profound silence descends. You wake up on a Tuesday morning in 2026. You reach for your phone, but its screen is a void, a smooth black mirror reflecting only your own confusion. Across the hall, the television refuses to flicker to life. The Wi-Fi router, usually a constellation of blinking green lights, is inert. This silence isn't just in your home, it stretches across the street. It stretches across the city. It stretches across continents. Every screen on planet Earth has gone black. This is not a simple power outage. A power outage is a local affair, an inconvenience measured in hours. The silence is the first clue. Cars with modern electronic ignitions won't start. The digital dashboards are dead. The radios broadcast nothing but static. You are disconnected, not just from the internet, but from the entire global infrastructure that you took for granted. To understand what has happened, we must journey to the heart of our solar system, to our star the Sun. It appears as a placid, unchanging orb in our sky, a reliable source of light and warmth. The Sun is a churning, violent inferno of nuclear fusion, powerful, tangled magnetic field lines. Sometimes these magnetic fields become so twisted and strained that they snap, releasing an astonishing amount of energy in an instant. This is a solar flare. Often these events are accompanied by something far more consequential for Earth, a coronal mass ejection, or CME. Imagine the Sun belching out a colossal bubble of magnetized plasma, a cloud of charged particles weighing billions of tons, hurled out into space. When a CME is aimed at us, it travels across the 93 million mile gap between the Sun and Earth in 1 to 3 days. As it approaches, it slams into Earth's magnetosphere. For the natural world, this is a spectacular light show. But for a technological civilization, it is a doomsday trigger. These wires act as giant antennas, soaking up the excess electrical charge and sending catastrophic surges through the systems they support. This is not science fiction. This has happened before. To see the proof, we must travel back in time to 1859. On the 1st of September, a British amateur astronomer named Richard Carrington was sketching sunspots. He witnessed an intensely bright flash erupt from the sunspot group. Just 17 hours later, the storm arrived. Skies all over the planet erupted in breathtaking auroras. The northern lights were seen as far south as Cuba, Hawaii. People in the Rocky Mountains woke up thinking it was dawn. The telegraph system, the 19th century's internet, was the first victim. Telegraph operators received literal shocks from their equipment. Sparks flew from the machines, setting papers on fire. The global network in its infancy had been brought to its knees by the sun. Imagine the Carrington Event in today's context. In 1859, the damage was limited to the telegraph network because that was the only large-scale electrical technology that existed. The world went on. It was a warning shot across the bow of history. A cosmic message delivered to a species on the verge of wrapping its entire world in sensitive electronics. Now let us return to that silent morning in 2026. What does a Carrington-class event do to our hyper-connected digital world? It triggers a cascade failure. The first domino to fall is the electrical grid. Geomagnetically induced currents surge through high-voltage transmission lines. They find their way into the massive transformers at electrical substations. Transformers the size of small cars, the workhorses of the grid, are not designed for low-frequency DC from a solar storm. They overheat, melt, and explode, hundreds, perhaps thousands across the globe. With the grid gone, the world goes dark. A massive modern hospital completely dark at night, with only a few handheld flashlights visible through the windows. Transportation grinds to a halt. Airplanes remain airborne for a time. Their navigation systems, reliant on GPS, are compromised. The satellite's sensitive circuits fried by charged particles. Planes would be flying blind. Airports on the ground are dark. Landing systems offline. Fuel pumps don't work. Hospitals become death traps. Backup generators might last for a few hours or a few days if they're lucky. Generators need fuel. Fuel pumps at depots require electricity. Patients on life support, ventilators, left with minutes. Dialysis machines fail. Refrigerated storage for medicines fails. Why 2026? Why this specific moment in time? The answer lies in the sun's own predictable yet powerful rhythm. Our star is not static, it goes through cycles of activity. We track these cycles by counting sunspots. During solar maximum, the sun is, well, an angry beast. We are currently in solar cycle 25. Early predictions said this would be a weak cycle, but recent observations show cycle 25 is far more active than forecasted. Sunspot numbers are climbing faster and higher than official predictions. The danger window centers on late 2025 and stretches into 2026. This isn't just speculation, it's a statistical probability. We can't predict the exact moment a CME will erupt, but we know the conditions that make them more likely. It's like Atlantic hurricane season. We don't know where a Category 5 will form, but we know the season. For Earth, the solar maximum is our cosmic hurricane season. We're sailing into stormy waters. History says it's not if, but when. The sun's timetable is pointing to the near future. The Carrington Event of 1859 may be the most famous solar storm, but it was by no means the most powerful. When a massive solar storm hits Earth, it bombards the upper atmosphere with high-energy particles. Those particles trigger nuclear reactions, converting nitrogen into carbon-14. By analyzing C14 in rings worldwide, scientists can pinpoint sudden dramatic spikes. One such event occurred in 774 AD. Tree rings from Japan, Germany, Russia, and North America show the same spike. That spike was about 20 times larger than normal solar variation. These are called Miyake events. Some scientists estimate 10 to 20 times more powerful than Carrington. In the 8th century, people saw auroras across the globe. Had it happened today, it would have annihilated our grid. Solar superstorms are part of Earth's environment, and the Carrington Event is not the ceiling. In the aftermath of the Great Silent Storm of 2026, the first question on everyone's mind would be, how long until the power comes back on? The answer is terrifyingly long. This is not a matter of flipping a few switches or repairing a few downed power lines. The core of the problem lies with the destroyed extra-high voltage transformers. Each one is a bespoke piece of engineering, weighing hundreds of tons and taking months, if not years, to build. Now, imagine hundreds destroyed simultaneously across a continent. The manufacturing capacity for these devices is extremely limited. In a normal year, the world produces a small number. After a global storm, every developed nation would scramble for new ones. The supply chain, specialty steel, copper wiring, insulation, would be crippled by a lack of power and by halted transportation. We would be in a catch-22. To rebuild the grid, we need industry. To have industry, we need the grid. A 2013 Lloyd's report estimated a Carrington-level event could leave 40 million Americans without power for 1 to 2 years. Costs could reach trillions. Those estimates assume a functioning society that can organize recovery. In a world without communication, transportation, clean water, or a functioning government, the task becomes exponentially harder. How do you move a 400-ton transformer with no trains or heavy lift cranes? How do you feed the people doing the work? The recovery would not be measured in weeks or months. It would be measured in years and more likely in decades. Society would be rebuilt from the local level up. We would live on a wounded planet haunted by silent, useless artifacts of a lost golden age. The vision of a world thrown into darkness is a frightening one, but we are not helpless. We are a species defined by our curiosity and our ingenuity. For every cosmic threat, there are brilliant minds working on a defense. We have a fleet of spacecraft, sentinels in the void, whose entire job is to watch the sun. This gives us our most valuable weapon, an early warning. A satellite at L1 detects a CME and sends an early warning signal to Earth. This could give us anywhere from 30 to 60 minutes of advance warning before impact. With that warning, power companies could perform controlled shutdowns of the grid, taking sensitive transformers offline to prevent them from overloading. Beyond early warnings, we can also harden our infrastructure, installing devices like series capacitors and neutral blocking devices that can absorb or block geomagnetically induced currents. We can also build up a strategic reserve of spare extra-high voltage transformers. Crews could deploy replacements from stockpiles, dramatically speeding recovery. For our vital satellites in orbit, engineers are working on more resilient electronics and better shielding. They are designing systems that can automatically detect dangerous radiation levels and power down safely until the storm passes. Understanding and defending ourselves against the fury of our own star is just the next great project in our cosmic journey. We have confronted the specter of a dark future. We've explored the science of the threat and the ingenuity of the solutions. Now the final question turns to you. Imagine you are there on that morning in 2026. The silence descends. The screens are all dark. The water supply, electric pumps fail. The food supply chain, grocery stores emptied. Trucks can't refuel. Communication breaks first. No phones, no internet, no television. Rumors and fear spread like wildfire. Trust in authority evaporates in hours. When your neighbor is no longer someone you can text, but a stranger you can only see across the street, how does that change your relationship? Do you have a plan? Enough food and water? Skills that don't need an outlet? Think about the dependencies in your life. This is a stress test for preparedness and resilience. In the first few hours, in the first few days, how do you organize? The sun will keep its cycles. Another Carrington scale event is not if, but when. It could be 2026 or a century from now. So what breaks first? And what will you do to hold it all together? So tell me, what do you think would collapse first if the lights went out? Comment your thoughts below, hit that like button if this gave you chills, and subscribe so you never miss the next impossible what if.